Okay, today I'm going to give you a quick tour of the code for Kaleidoscope in MakeCode Arcade. This is a blog post that I have just finished about the code, and it goes into a great deal of detail about each aspect of the code in Kaleidoscope. So there's where you get the real detail at WeCodeMakeCode.com. Now, what does the code look like? Well, before we look at the code, let's do something here. Okay, this is Kaleidoscope. Now, if I long press A, it's going to give me some options. Well, I want to pause after each line, and I don't want to change anything else. Now, notice it's drawing from the center, which is origin, to a point on the perimeter, starting with the corner and then continuing all the way around and then all the way around again and blah, blah, blah till it gets around here. Well, notice that it is has the colors it's using is displayed down here at the bottom of the pattern. And what it will do is it will go through one palette of colors, then it will add one color to the palette and then go around again. So as colors are added to the palette, the pattern becomes more and more complex. So I'm describing this in detail so that you'll understand, what the code is doing. So let's go back to the code. Now, an overview of the code is this. I like to organize my most important code, the main code, at the top of the program, and then have the more detailed, or the subroutines or the subfunctions down, 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 down. So at the top, I like to have my initialization here on the left. Then I have my looping, like the forever loop or the on-game loop here in the middle. And then over here, I have my input functions where the player interacts with the program. Now, sometimes you would have on collision or events. This program has no events, so don't look for them. So this is the main initialization loop. You know what initialization is. That's where you set up the variables you need and the defaults and the minimums and the maximums and all that kind of stuff. This block asks the player if they would like to have instructions. And if you just say no, it continues on. You saw that. I think I showed you that earlier. If not, I showed it to you in last week's video on how to use Kaleidoscope. This program calls initialize and make new field, and it calls call instructions to actually get the instructions. Well, initialize is just more initialization, but it's separated from the other initialization because this initialization is called at another time. In fact, it's called right there. And you'll understand why later. So that's why initialization of variables is set into two different things. Now, make a new field means make a new layout around which to draw lines. So it calls a function called set sprites and background, and it calls set the origin. The origin is the center or the place from where the lines are being drawn, and it may not be the center because the player can move it with the arrow keys. It initializes the perimeter array, which I'll show you that in a minute. That's just arrays X and Y, which contain the X and Y value of all the points around the perimeter of the rectangle that is the pattern. I found it easier to do it in an array because drawing the lines was smoother if I did that. Then call set output sprites. Well, that's just because I like to give the player some output using sprites rather than the long text, because with sprites I can tell it how long to stay on the screen and the user doesn't have to tell it to go away. You have to assume that players are lazy. Okay, this is my forever loop. It runs forever, well, until the player stops it. The You saw in the little demo of the program how the lines start from the origin point and draw to points around the center, around the perimeter, going initially from left to right. And you saw on the bottom where the colors are, the palette, it adds one color at a time to the palette until it has used all the possible colors, and then it starts over creating a new pattern. There's one trick about the colors. The number of colors must be a factor of the number of points in the perimeter. Why is that? Well, because the colors need to come out even so that the last color drawn will be the last color in the palette, so that it will be the first color drawn is the first color in the palette. Therefore, the corner that comes together at first and last will be the same as other corners on the palette. That is, the colors will advance smoothly around. Otherwise, you might actually get 2 points of the same color where the first and the last intersect. Now, that's very complicated. Trust me, it needs to be a factor. A factor simply means that if you divide the number of points in the perimeter by the number of colors, the remainder needs to be 0. So it just advances the number of colors, adds one down here, but it only uses it, only does something if it's a factor. And what does it do? Well, it waits until not paused. It might be paused. The program might be paused, and in that case, it's waiting for the user to touch B or to long press B in order for the pattern to advance. Then it calls set the next palette, so it gets the next palette, and it does calls do pattern to actually do the pattern. Now, do pattern is another very important routine in the program. And what it does is it simply goes round and around from 0 to the number of points in the parameter. So it draws every line all the way around, always starting from the origin. So here's where we draw from the origin to the point x, y that we pulled out of these two arrays. And we did it with color, which we had gotten by the fact right here it said get this color, which is the color you're going to use, and then it calls draw from origin to x, y. And there is the line. Notice it's drawing in the background image, which is the image within the background sprite. Now this is the get next color, which just advances it advances to the next color. This is set the next palette, which is a little more complex. What it does is it adds one color to the palette. The number of colors in the palette starts out at 2, and then it increases one color at a time until it's used as many colors as there could possibly be, which is 15. But this is called only with the number of colors that is a factor of the perimeter. So it adds as many colors as it needs in order to get to that number of colors. Another little cute thing this routine does is it makes sure that no 2 colors are consecutive. And I did that. That doesn't have to be done, but it actually made, I thought, for nicer patterns. Okay. Now all these brown or orange thingies are buttons, and this is the up, down, right, and left. And notice that these are all repeats. This is where you move the origin, and I found it wasn't useful to move the origin just one point at a time, so it only moves them up when you hold the arrow key down. And I made a little routine that actually does adds to the X and Y locations of origin, just because it made the code here simpler. Then the A and B buttons, they a little more complicated, but if you think through how the user uses the A and B buttons, you'll see that these do exactly what you want to do. Okay. Now, what else should we talk about? What else is really interesting? You know how to set sprites. There's where we set the origin sprite. and which each starts out at the very center. This is a good place to say that there needs to be one pixel at the center of the pattern. If there's not one pixel at the center, then the balance will be, then it will be wackadoodle. So the pattern will be. You don't want your patterns wackadoodle. So to do that, what you want to do is make the perimeter, you want the width and length to be odd numbers so that there will be a center pixel. And this is where we set the background sprite and so on. Okay. And we've talked about the palette. And then this is where we display colors. This routine is pretty simple. It just creates a panel, which is a sprite, and it puts the colors in there that are currently being used. And a fun thing is that it calls this little routine called doChecker. And let me just show you. Well, I think I can show you over here. Okay. This is from the blog. This shows this is the palette, and this is the checkerboard palette that it puts the colors of the palette on. And as a palette progresses, it adds colors over here on the left, and then it will add them up until it gets to as many as it can have. The reason I have the little checker thingy there is because if I put these colors directly on the pattern, it's kind of confusing with the pattern itself, so this causes it to stand out. Now remember, if you don't want the pattern, you can cause it to go away just by, when the patterns are paused, if you strike the A key button, the patterns go away. Now, what else is fun? Okay, the next thing that's kind of fun is, well, there's the routine that, oh, this is the perimeter array. Let's do that. Okay. This initializes the perimeter array, and this has to be called every time that width and length height changes, because they're the different array. Okay, so it sets up these AX and AY variables, and it does it brute force. That is, it indexes all through one side, or this goes through the top, this goes through the right side, etc., putting values in there so that all of the perimeter points are in the array. Wow, it got dark in here. You're now seeing me by monitor light, which is how I kind of live my life. Okay, here's where we get options from the player, and this just asks several things, which are kind of apparent. And it calls a function. If it needs a value from the player, it calls a function to do that. Here's where it gets the width, and of course the width has to be within certain limits, or it goes back to the default values. And this is the weight between patterns, which is settable. And then there's these routines that get some kind of number and check it for limits. Odd integers, get an integer, is it with, checks the limits, is it a decimal, and is it digits only? So all those kind of call down until it gets what it needs. Then at the end, there's this message default means this is called by those number checking functions that if it's out of bounds, then it says the text passed by the routine that was checking the bounds, and it outputs that and then waits for the user to see it and goes on. Debug say and wait is one of the output routines that I said I use, and then this is the one that sets the output sprites. And here is destroy sprite. This is interesting. If you try to destroy a sprite that doesn't exist, come on, the program sort of does not do what you want. So this routine checks to see if the sprite is null, that is, it doesn't exist, and destroys it only if it exists. Now, what I wish is if there was some way to do this just in blocks without doing this JavaScript gadget, because if I have my program mostly built before I do this, and I have to go into JavaScript to do this, then when I come back, all of my code layout is totally screwed up. And I am very irritated by that. So I won't go on any more about that. Okay, let's see if there's anything else I should show you about this wonderful code. What's that over there? Oh, that's the random field stuff. If you have, if you've elected the option to do random patterns, then this will get the random field dimensions, generate the random field dimensions and make sure they're odd and provide them, and then it goes back and we can go up here into the main loop and see that. See, there is the, if there is a random field, it waits till it pauses over, gets the random field dims, which is what I just showed you, and it makes a new field. So that's it. That is all the code. If you need any more help, you may go to the blog, and I hope you find the code kind of self-documenting. It does require a little brain power. If you get confused, it's good to draw things so that you can then understand them. And I will stop now. You have a great life. Bye.